Everyone, welcome back. Today we're going to be talking about theorems that involved the interior angles and also one postulate that we can use when we're talking about interior angles that are formed when we have two parallel lines cut by transversal. Let me show you an example of what that looks like in case you got lost. So here's what I was mentioning. Whenever we have two parallel lines that are cut by a transversal, which is that line, there are some theorems that talk about these interior angles, or what we call interior angles, which are these that are in the inside of those two parallel lines. Any angle that's inside those two parallel lines are what we call the interior, and angles that are on the outside, those are our exterior angles. So today we're going to focus on the ones on the inside. And the first theorem we're going to look at is the Alternate Interior Angles Theorem. And this theorem simply states that angles that are in the inside and on opposite sides of our transversal, which again is this line, these two angles are actually congruent, meaning they equal each other. Angle 1 and angle 2 have the same exact measurement. So, to give you a simple example, if I am given that the measurement of angle 1 is equal to 100 degrees, I can say that by the Alternate Interior Angles Theorem, that the measurement of angle 2 is also 100 degrees. Okay, and this would be by alternate interior, it's quite a long name for a theorem, but that's okay, angles theorem. This is just one example of how we use it. The other alternate interior angles that we have here, they're not labeled, but these two angles here would also be equal to each other. Okay, so if I had one of those, I'd be able to give you the other as well. A lot of times in geometry, we use the fact that, hey, you know what? I know one of them, so by this theorem, I also know the other one. We use this concept quite a bit in geometry. The other interior angles sort of rule, which we actually call a postulate, is the Same-Side Interior Angles Postulate. Okay, and what this tells me is that my interior angles that are on the same side, so for example here, angle 1 and 2, they're inside those parallel lines and they're both on the same side of this transversal. These two angles are supplementary. The Same-Side Interior Angles lets me know that if I were to add these two angles, I would get 180 degrees. Okay, so how do we use that? Well, a lot of times they'll give me one of the angles and I use this postulate to help me find the other. So for example, let's say I'm given that the measurement of angle 1, which would be this angle right here, they tell me that that measurement is equal to 110 degrees. Then I would be able to use the Same-Side Interior Angles postulate and write this equation that says the measurement of angle 1 plus the measurement of angle 2 is equal to 180 degrees. Well, then I can simply substitute the 110 for the measurement of angle 1. I'm going to plug this in for the measurement of angle 1 since I know it. 110 degrees plus the measurement of angle 2, that should equal 180 degrees. I can then simply subtract this 110 from both sides, and I'd end up with the measurement of angle 2 equaling, if I do this correctly, nope, sorry, 70 degrees. And this is how we use the Same-Side Interior Angles Postulate to our benefit sometimes. Well, actually quite a few. And as we just learned from the other theorem, the alternate exterior, I now know that this is 110, and I know that this angle would be 80. Based on the theorem that we just saw, the Alternate Interior Angles Theorem, I know that this angle, even though it's not labeled, I could say that's 110, and I could say that this angle is 80 degrees. Sorry, I wrote that in red. 80 degrees. Sorry, not 80. What am I doing? 70 degrees. And we use this, again, a lot when we're trying to write proofs, when we're working with triangles, and other concepts in geometry. So hopefully now you understand these angles a little bit more when we're talking about interior angles that are inside two parallel lines that were cut by a transversal. What I'd like you to do next, if you can, watch this next video on theorems that involve exterior and interior angles, and as well as only exterior angles. So if you have time, check that out. But as always, I just want to thank you guys for watching, and I'll see you guys next time.